Thank you for joining this lesson. We're going to do number 12 from linear inequalities, where we are told to determine the inequalities that represent and satisfies the unshaded region. So the unshaded region is the required region in here. Therefore, we should know that these lines are called borderlines and they are representing some inequalities. Therefore, we're first going to get the straight lines equations before we determine the inequalities themselves. Therefore, this is a vertical line, which means it's a line of the form x equals to a certain value. So x equals to, this is 1. So x equals to 1. Now that x equals to 1, we are going to consider the values of x on the required side and the values of x on the unwanted side. So we can see on the required side, the values of x are greater than the unwanted side. Therefore, it is x greater than 1. We want the values of x which are greater than 1. And something else we should know, because the line is complete, it is not a dotted line, then we are going to say, apart from greater than, x is also equal to 1. So this is the first inequality. The second one, we're going to consider this other borderline here. This is line, an horizontal line, which means it is a line of y equals 2, and it is y equals to 0, or rather the x-axis. So if y equals to 0, we can see the values of y being 1, 2, 3 is the wanted side, but the one where the values of y are smaller than 0 is not required. The line again is complete. Therefore, the line is going to be y greater than 0, and because the line is complete, or equal to. This is our second inequality. Finally, we have this other borderline, which is a dotted line, or rather incomplete line. It means the line cannot be greater than or equal to. Then we are going to do this. For us to know the equation, we're going to consider two lines along the line. So we have two coordinates along the line. That is, we have coordinate 3, 0, and we also have 0, 3. So the first thing we should do is to get gradient now. So gradient is going to be, so we can have a gradient like 3 minus 0, then 0 minus 3, because it is change in y out of change in x. So 3 minus 0, 0 minus 3. So this is going to be 3 out of negative 3. So the gradient is going to be negative 1. Now that we have gradient, we're going to express the gradient and one of the coordinates. Take, for instance, this one, so that we may say y minus 0, then x minus 3 to get the equation. So that this becomes y equals to negative x positive 3. So this is going to be the borderline. But now, if we pick a coordinate on the required side, let's say a coordinate 1, 1, because it is on the required side of this borderline. So coordinate 1, 1, for instance, we will have y as 1 equals to, okay, let's avoid the equals to. So where we have y, we put 1, and where we have x, we also put 1. So negative x is going to be negative 1 plus 3, which makes it a 2. How is 2 and 1 related? So we are saying that 1 is less than 2. So which means at the point of the equal sign, we shall have the sign of the inequality, whereby it will be less than. I said we will not say equal to, because the line is dotted. X plus 3. This is going to be the third inequality satisfying the given region.